Practice exam number 22. There's an equation given in the handbook for isothermal compression that includes the molecular weight of gas M. Why is that not included in this solution? And when do you use the equation that includes the molecular weight? So this is a classic thermal properties equation right here for finding the work for an isothermal process, a compression process. So we have the pressure ratio, the mass flow rate is in there, the temperature. They've included the efficiency. You may or may not see that. If it's not included in the problem statement, maybe you assume it's 100%. But the question really comes down to why in my solution I just used R, and in this equation it's R bar over M. And the answer comes down to the distinction between the universal gas constant and the specific gas constant. So we probably covered this at one point, but if you forgot, that's totally okay. The specific gas constant for any gas can be calculated as, and the specific gas constant gets the variable R, that can be calculated as the universal gas constant, R bar, and you may sometimes see this as R star in other texts, or just a bolded R, which I don't really have the ability to do that on a whiteboard like this, but the reference handbook likes to use R bar, so we'll stick with that nomenclature. If you take the universal gas constant and divide it by the molecular weight for a gas, you get the specific gas constant. So the fact that the reference handbook offers up specific gas constants for a variety of different gases is really being done for your convenience so that you don't have to do this work. Technically, they don't have to give you any of the specific gas constants. You can get the universal gas constant and divide by the molecular weight. So if it's air, that's I never say memorize things, but if you use these things enough, you may find that you do remember them eventually. So if you wanted to know the specific gas constant for air, it's going to be 53.35 with units foot-pound, force per pound mass, Rankine. And that's what I used in the solution video. But if you were coming to this equation and you wanted to use it, you certainly can. Just take the universal gas constant and divide it by the molecular weight of air, which is about 29. I don't know what units you want to use, but if it's SI units, you might say grams per mole. If it's US customary units, then you're more likely to say pounds per pound mole. And we can get into the detail on that. But, if it was pure oxygen, it would be 32, and nitrogen would be 28, and anything else. And that's kind of a good way to remember this is 29, because what is air? Air is a mixture that's about 3/4 nitrogen and about 1/4 oxygen, with some other smaller contributors like water vapor and whatnot. So if that's not fresh in your mind, you can consult the periodic table. If these are foreign ideas to you, I think it's a good idea to work through some of this stuff, go look at the periodic table, go find the universal gas constant in the reference handbook to make sure you can. If you've done a lot of practice problems already, this stuff may be second nature to you, but if it's not, then that's an area to go and just stress making sure you can run through that.